Hello everyone, myself Ankur Patel, and today in this third session of projection of lines, we will practice problems in which n projectors of the lines are given. And n projectors of the lines are the data related to the plan length and elevation length of the line. So before starting the practice of problems, let us discuss what are n projectors and how can we find the true length and true angle of inclination of the line if the plan length and elevation length are known. So here in this figure we have represented the elevation and plan of the line AB. So A dash B dash is the elevation of line AB, which is inclined at an angle of alpha to the XY reference line, and AB is the plan length of or plan of line AB, which is inclined at an angle of beta to the XY reference line. So A dash is the elevation of end point A of the line, and A is the plan of end point A of the line. And a line connecting A dash A is known as the projector of end A of the line. Well, B dash is the elevation of end B of the line, and B is the plan of end B of the line, and a line connecting B dash B is known as the projector of end B of the line. So we can say that the perpendicular distance between the projector of A and projector of B is known as the n projectors. So if the length of the n projectors are given and locus of A and locus of B are given, then we can mark elevation and plan of endpoint A and endpoint B at the given length of the n projectors. Now let us discuss how can we find the true length if plan length and elevation length of the lines are known. So let's try to find out the true length. So first of all, if you want to find out the true length in the plan side, then take A dash as the center and radius is equal to A dash to B dash. Give an arc up to locus of A dash. The arc cuts the locus of A dash at B2 dash. Now from B2 dash draw a straight line up to locus of B. This intersection will give us the B1. Now connect B1 to A, we will get the true length, which is inclined at an angle of phi to the XY reference line, and phi is the angle of inclination of the line with the vertical plane. Now measure this true length AB1, put your rounder on A dash, that means take A dash as a center and give an arc on the locus of B dash. We will get B1 dash here. Now connect B1 dash to A dash. This will be our true length inclined at an angle of theta. So theta is the angle of inclination of the line with the horizontal plane, and theta and phi are also known as the true angle of inclination of the line. Now we can also find this B1 dash by the alternate method. For that we have to rotate AB about A. So take center at A, radius is equal to A to B, give an arc up to locus of A. Here we will get B2, and from B2 draw a straight line up to locus of B dash. Here we will get B1 dash. So we can also find B1 dash by using this method. So by using this particular method, you can find the true length and true angle of inclination of the line when plan length and elevation length of the lines are known. So let's start with the first problem of n projectors. The distance between the n projectors of straight line AB is 60 mm. Point A is 5 mm above HP and 30 mm in front of VP. Point B is 40 mm above HP and 50 mm behind of VP. Draw the projection and find the inclination of the line AB with HP and VP, and also find the true length of the line. So the given data is the distance between n projectors is 60 mm. So EP is equal to 60 mm. A is 5 mm above HP, 30 mm in front of VP. A is 5 mm above HP, 30 mm in front of VP. B is 40 mm above HP, 50 mm behind VP. B is 40 mm above HP, 50 mm behind VP. Draw the projection and find the inclination of the line AB with HP and VP and true length of the line. So here we have to find the inclination of the line AB and true length and theta. So true length, theta, phi. Theta is the angle of inclination of the line with the horizontal plane, and phi is the angle of inclination of the line with the vertical plane. And we have to find out the true length also. So let's start. First of all, draw XY reference line. Now mark point A, or before marking point A, first of all mark n projectors. So first of all mark n projectors EP. Now we are going to mark point A, that means the plan and elevation of point A. A is 5 mm above HP, 30 mm in front of VP. So above the XY reference line 5 mm, we will get the locus of A dash, and 30 mm in front of VP. That means 30 mm below the XY reference line, we will get the locus of A. Now let us consider this projector as the projector of A. So we will get A dash over here and A over here. So A dash will be the elevation of endpoint A, and A will be the plan of endpoint A. Now let us mark B. So B is 40 mm above HP and 50 mm behind of VP. So 40 mm above the XY reference line, we will get locus of B dash and B1 dash, and 50 mm behind VP. That means 50 mm above the XY reference line, we will get locus of B and B1. Now as we have assumed that this projector as the projector of A, this will be the projector of B. So we will get B over here, that is plan of point B, and B dash over here, that is elevation of point B. Now connect AB will be our plan length, and the angle of this plan length will be beta, and connect A dash B dash will be our elevation length, which is inclined at an angle of alpha to the XY reference line. Now after getting plan length and elevation length, we have to find out the true length. So to find the true length, first of all, if you want to find out the true length in the elevation side, take A as the center, radius is equal to A to B, give an arc up to locus of A. Here we will get B2. Now from B2, draw a straight line up to locus of B dash. So here we will get B1 dash. Now connect B1 dash to A, will be our true length at an angle of theta. Now if you want to find out the true length in the plan side, then take A dash as a center, radius is equal to A dash to B dash, give an arc up to locus of A dash. Here we will get B2 dash. Now from B2 dash, draw a straight line up to locus of B. Here we will get B1, and connect B1 to A, we will get the true length, which is inclined at an angle of phi. So phi is the angle of inclination of the line with the vertical plane, theta is the angle of inclination of the line with the horizontal plane, and we will get the true length. So measure true length by using the scale. We will get true length is equal to 103 mm. Measure theta by using the protractor. You will get theta is equal to 30 degree, and measure phi by using the protractor. You will get phi is equal to 45 degree. So this is our final answer. Now let's move on to another example. Example number 2. A line CD has its end C 15 mm above HP and 10 mm in front of VP. The ND is 60 mm above HP. The distance between the N projectors is 50 mm. The line is inclined to HP at an angle of 25 degree. Draw the projection and find its inclination with VP and true length of the line CD. So here the given data is N projectors of the lines is 50 mm, or we can say that C is 50 mm above HP and 10 mm in front of VP. D is 60 mm above HP. Another locus of point D is not given. The distance between the N projectors is 50 mm, so EP is equal to 50 mm, and line is inclined to HP at an angle of 25 degree. So theta is equal to 25 degree. Now here the locus of D is not given, or we can say that the half locus of point D is given. So from this data we will get D dash only, that means the elevation of D only. D doesn't get the plan of point D. But in place of that data, theta is given. And we have to find out the angle of inclination of the line with the vertical plane and true length of the line. So we have to find true length and angle of inclination of the line with the vertical plane, that is phi. Now D is 60 mm above HP. That means either it will be in the first quadrant or it will be in the second quadrant. So first of all, let us assume the quadrant of point D. So assume point D in the first quadrant. Now we can say that D is 60 mm above HP and it is in front of VP. Now start with the XY reference line, and first of all mark the N projectors, which is 50 mm. Now C is 15 mm above HP, 10 mm in front of VP. So above the XY line 15 mm, we will get locus of C dash, and 10 mm in front of VP. In front of, that means plan of point C will be 10 mm below the XY reference line. So 10 mm below the XY reference line, we will get locus of C. Now assume that this is the locus of or projector of C. So we will get C dash over here exactly and C over here. So C dash will be the elevation of endpoint C and C is the plan of endpoint C. Now D is 60 mm above HP. Above, that means elevation. So from the XY reference line, 60 mm above the XY reference line, we will get the locus of D dash and D1 dash. And as we all know that D dash and D1 dash will be on the same locus. Now as we have assumed this as a projector of C, this will be the projector of D. So here we will get D dash, and somewhere below the XY reference line on this projector we will get D, that is the plan of point D. We will get the plan of point D below the XY reference line on this projector of D. Now let us follow the given data. Now here if we connect C dash to D dash, we will get the elevation length which is inclined at angle of alpha. Now another data which is given is theta. Theta is 25 degree, and we all of you know that we can draw theta angle from C dash. So draw line inclined at angle of theta from C dash. Theta is 25 degree, and mark the intersection point of this line to locus of D dash. We will get D1 dash over here. So this will be our true length. So right now we get the true length. Now we have to find out the plan length and true length in the plan side, because if you want to find out the angle phi, we have to find out the true length in the plan side also. So now if you want to find out the plan of point D, first of all draw straight line from D1 dash up to locus of C. Here we will get D2, and now C D2 is our plan length. We have a plan of point C, but we doesn't have plan of point D. It will be somewhere over here. So take C as a center, radius equal to C to D2, and give an arc and mark the intersection point of this arc to projector of D. We will get D. So this will be the locus of D and D1. Connect D to C. We will get the plan which is inclined at angle of beta. So beta is the angle of inclination of the plan of the line CD with the XY reference line. Now measures this C dash D dash, which is our true length. Take center at C and give an arc on locus of D and D1. We will get D1 over here. Connecting D1 to C, we will get the true length which is inclined at angle of phi to the XY reference line. Now measure this true length, which is equal to 105 mm, and we have to find out the phi also. So measure this phi angle by using the protractor. We will get the phi is equal to 50 degree. So this is our final answer. Now let's move on to next example with some different data with N projectors. So the N projectors of the line PQ are 35 mm. Again N projectors are given, which is 35 mm. The end point P of the line is 10 mm above HP and 15 mm in front of VP. The front view and top view of line measures 50 mm and 60 mm respectively. Draw the projection of the line assuming Q in the first quadrant. Here the quadrant of point Q is already given. Also find the true length and true inclination of the line with HP and VP. So we have to find out the true length and true angle of inclination with HP and VP. So the given data is N projectors of the lines are 35 mm. So EP is equal to 35 mm. P of the NP of the line is 10 mm above HP, 15 mm in front of EP. So P is 10 mm above HP, 15 mm in front of EP. And here the front view and top view, that means the plan length, the elevation length and plan length of the lines are given. So the front view measures 50 mm, so front view or elevation is 50 mm, and top view measures 60 mm, so top view or plan length is equal to 60 mm. Now after drawing the projections, we have to find out the true length and true inclination of the line with HP and VP. That means we have to find out the true length and theta phi. Theta is the angle of inclination of the line with the horizontal plane, and phi is the angle of inclination of the line with the vertical plane. Now here the quadrant of Q is already given. So Q is in the first quadrant, and assuming Q in the first quadrant, we will draw the projection of the line. So first of all, draw XY reference line, and as this is the example of the N projectors, first of all mark the N projectors, which is 35 mm. So mark the N projectors 35 mm. After marking the N projectors, let us try to find out the plan and elevation of point P. So P is 10 mm above HP. So 10 mm above the XY reference line, we will get the locus of P dash, and it is 15 mm in front of VP. That means 15 mm below the XY reference line, we will get the locus of P. Now consider this projector as the projector of P. We will get P dash over here and P over here. So this will be the elevation of P, which is P dash, and this will be the plan of endpoint P. Now the further given data is front view, that is elevation length, and top view, that is plan length, and Q is in the first panel. So we will get the Q dash somewhere above the XY reference line on this projector, and we will get plan of point Q somewhere below the XY reference line on this projector. Now front view and top view are given, so measure the front view, which is our elevation length, which is 50 mm. Take center at P dash and give an arc on the projector of P. Projector of Q. Now as we have considered this as the projector of P, this will be the projector of Q. So here we will get the Q dash, because we have taken this arc having length is equal to 50 mm, and 50 mm is our elevation length. So by connecting P dash Q dash, we will get the elevation length and the angle of the elevation length, which is alpha. Now measure top view, which is 60 mm, and take center at P and give an arc on projector of Q. So here we will get the plan of point Q. Connect PQ will be our plan length, which is inclined at angle of beta. So this will be the locus of Q dash and Q1 dash, and this will be the locus of Q. Now further we have to find out the two length, theta, and the phi angle. So now how can we find the two length if plan length and elevation length, if plan length and elevation length of the lines are known? So let's try to find out the two length. So first of all, take P dash as a center, and radius is equal to P dash to Q dash. Give an arc on the locus of P dash. Here we will get Q2 dash, and from Q2 dash draw a straight line on locus of Q. So here we will get Q1. Now connect Q1 to P. This will be our two length, and the angle of these two length is phi. So phi is the angle of inclination of the line with the vertical plane. Now measure this two length, that is PQ1. Take center at P dash and give an arc on locus of Q dash. Here we will get Q1 dash, and by connecting Q1 dash to P dash, we will get the two length, which is inclined at angle of theta. Now measure two length by using the scale, which is equal to 70 mm. Measure theta by using the protector, we will get theta is equal to 30 degree, and measure phi by using the protector, we will get phi is equal to 45 degree. So this will be our final answer. So this is it for today. We will come with some more problems of projection of lines in our next lecture. Till then, take care. Thank you.